Here you can see the entire note of the existence of electron spin. What I told to you that I will provide you this note. Okay, this is the entire note, 6 pages. Entire note is your 6 pages. Page number I have been provided over here. 1, 2, 3, 4, 5, 6. I derived step by step. Okay, here I'm going to first explain in short what we have been discussed in our class. Then after I will say you that if this question will be asked in your exam, how much you have to write for your 3 to 5 mark question. Okay, here the Dirac's Hamiltonian in a stationary central field having potential Vr is represented by this one. Already we have been discussed C alpha dot P plus beta m naught C square plus Vr. Let this is your equation number 1. And we know that the torque upon a particle is 0 when the particle moves by influence on central field. That we know. That means the tau will be equal to 0 in your central force field. That implies rate of change of angular momentum will be 0, or you can say angular momentum is equal to constant quantity or conserved quantity, or r cross p is your constant or conserved. Now we have to validate this is true or not by considering Dirac theory or not. Same thing I have written. See, now we have to validate this is true by considering Dirac theory or not. Okay, it is well known that quantum mechanics in quantum mechanics any operator that commutes with Hamiltonian is a constant of motion. That means suppose A is a operator commute with Hamiltonian. That means A commute with Hamiltonian means this will be 0. Then A is a constant or conserved quantity. That we have to find, that we have to just check is the angular momentum here is conserved or not. For that we considered the x component of angular momentum. So Lx h is nothing but Lx h, whatever I written in the equation number 1, same I written over here, this one, C alpha dot P plus beta m naught C square plus Vr. Okay, here I written same thing. Then here alpha dot P is nothing but your alpha x px, alpha y py, alpha z pz. Here Lx, here how many terms? We can get 1, 2, 3, 4, 5 terms if I'm going to consider the entire computation. So here Lx, this term C alpha x px, Lx alpha y py, Lx alpha z pz, Lx beta m naught C square. Here I written Lx Vr. Okay, let this is your equation number 2. And you can do by your rough, you can found this commutation, these commutations C alpha x px, Lx beta m naught C square, Lx Vr will be equal to 0. Now the equation number 1, these are will be 0 means this term will be 0, and here m naught C square, this term will be 0 and this term will be 0, and rest the 2 terms are this one I written over here. Let this is your equation number 3, right? Right. Now consider this term first. What will be the value? This one, Lx C alpha y py. First you just go through this video, what I am explaining, try to understand, and after that I will say to you how much you have to write. Okay, so no, don't worry about that. Here Lx C alpha y py, if I'm going to consider C and alpha is the constant quantity taken outside, because now here alpha x is just alpha y is your scalar, so C alpha y taken this side, Lx py. Lx x component is nothing but y pz z py, and this is your py. So here y pz commute with py written over here, and then minus z py with py written over here. So this one here y pz py can be written like this. Here y taken this side, then pzy plus pz will be taken this side, y pz y py pz, like this can be written by these 2 terms. And commutation of pz py we know 0, py itself 0, z py also 0. So what we found, the value of this term will be equal to here C alpha y, here y py is nothing but IH cross pz. Let this is your equation number 5. Now similarly this value, commutation value, we can found this one, alpha C alpha z minus I h got py. Let this is your equation number 5. We have to put these 2 equations 4 and 5 in equation number 3. Here in equation number 3, if I'm going to put over here this value and this value, and here we can found this one. Okay, that means this one, which is not equal to 0, so equation number 6 what told represents that Lx and H are not commute. See, these points are very much important that you have to write in your exam with each other. That means Lx not constant or conjugate. Similarly, we can get Ly, Lz also not constant or conjugate. Here it is found that most important points here. So in your exam, no need to derive these things direct by consider by after derivation we can found this term Lx h will be equal to 0, which is not conjugate. Okay, okay. So here it is found that in Dirac theory, orbital angular momentum, that means L, does not commute with h or not a constant of motion according to Dirac theory. However, logically, if the system, suppose you just consider hydrogen atom is well developed, nucleus is there and one electron revolving around this nucleus, this system is true. That means if the system is true, then on the physical ground it is possible to define a total angular momentum. That means if I here we consider one single angular momentum of this electron which is revolving around the nucleus, which is and not commute with h, not commute with h. So simply if not commute, then total angular momentum that is constant in a central field. That means some angular momentum should be constant here. So only for that it is written that total angular momentum will be constant, should be constant. What is the meaning of that? That means we must find another operator, not only L, a additional term with L should be there, which will satisfy the total angular momentum. What it is written? That means we must find another operator such that the commutator of its x component. Suppose we consider another operator t, suppose, and its x component. If I am going to consider its commutation with h, that means this value should be equal to and opposite to this 6 value. That means should be, here it is negative. This commutation value will be how much? Will be positive of this value. Then we can say that here Lx plus Tx h will be equal to 0. Got it? That means here we have to search another operator such that the commutator of its x component with h equal and opposite of RHS of equation number 6, what I explained over here. Okay, RHS of इक्वेशन नंबर 6, इक्वेशन नंबर 6 का जो RHS में जो टर्म है उसका साथ इक्वल होगा, ऑपोजिट होगा, देन जाके सेटिस्फाई हो सकता है, देन इट विल सेटिस्फाइड. सो दैट द सम ऑफ दिस ऑपरेटर मींस tx, suppose we consider and L, here I written same thing, tx Lx plus tx will be commute. Okay, is a constant. Okay, Dirac in this, that means these lines you have to write, which are most important in your exam. These lines you have to write. Okay. Okay. Now Dirac in his research work was found that a constant factor multiplied with a sigma dash is the desired operator. So here Tx cap, Dirac searched in his research work what will be this operator, and he found that sigma dash is the operator, but it will be some multiplied with some factor with sigma dash is the desired operator. He found in his research work, whose sum with L is the constant of motion. Okay. Okay, then we have to evaluate the multiplied factor by considering sigma dash. So these derivations are not required in your exam point of view, but here I am explaining what I written in your note. In future it will be required for you. So okay, so here we know that the sigma dash matrix is this one, x component we taken this one, and now we are going to consider the commutation with h. That means its x component h will be written as like this, and alpha dot p is nothing but this one. Here sigma x commute with every quantity of above equation except alpha y, alpha z. Here I have been verified. These things not required for your exam, I am telling to you. Okay, not required for your exam. Here you can verify. See, sigma dash beta. So if I am going to write a whole of this bracket, so how many commutation we can found here? One term, 1 2 3 4 5. So sigma dash x dash commutation with beta here will be equal to 0. Sigma x dash alpha x, if I am going to consider, will be equal to 0. Okay, but and vr also, because vr is one type of constant, so obviously it will be 0. But with alpha y, that means with these two terms, it could not be commute. So what will the value, that we have to find out. So now equation number 7 here, if sigma dash x dash will be commute with all the terms except alpha y and alpha z, then equation number 7 what we can write this much, all the terms are vanished. So equation number will be this one. Now this can be written as by two terms, commutation with this one with this sigma dash x with this one plus this one. Okay, okay. So here you can write this one as like this. Here alpha y taken, c is a constant taken outside, alpha y sigma x dash py plus sigma x dash alpha y py. See, this taken outside this side, py taken this side. This procedure we know. Okay. Similarly, this can be written by the two terms. Here sigma x dash py will be equal to 0, and sigma x dash pz commutation also will be 0. So now we are going to find out this value. Sigma x dash, that implies sigma x dash h will be these two terms. C is the constant taken outside, this term and this term. Let this is your equation number 8. Now we have to evaluate this one. Sigma x dash, this is important for you, for your understanding purposes. No need to write in your exam. How much you have to write, finally at the end I will tell to you, just wait. Sigma x dash alpha y is this much. Okay, commutation, if I am going to apply this minus this, sigma x dash matrix format is nothing but sigma x 0 0 sigma x alpha y 0 sigma y 0, and alpha y written in the matrix format, sigma x dash written in the matrix format. Just multiply these two matrices, we can get this one. By multiplying these two matrices, we got this one. Okay, okay. So here sigma y sigma x is nothing but minus sigma x sigma y. Here sigma y sigma x is nothing but minus sigma x sigma y. Sigma x sigma y, this is the Pauli matrices, is nothing but I sigma z. Here also I sigma z, this will be minus I sigma z minus I sigma z. Okay, taken I common from this matrix, we can get 0 sigma z 0. Here also 0 sigma z 0 minus I taken common from this matrix, so this will be plus. So here we can get 2y 0 sigma z 0. This matrix is nothing but your alpha z. Let this is your equation number 9. So here commutation of these two operators, we found 2y alpha z. Similarly, commutation of sigma x dash alpha z, we can found minus 2y alpha y. Here equation number 9 and 10 we are going to substitute in equation number 8. Here equation number 8 is this one. Here I am going to substitute this value and this value. So what I can write, c is there already, c, and here this value is nothing but 2y. Here 2y alpha z I am going to substitute over here, 2y alpha z. Here minus 2y alpha y I have to substitute over here, minus 2y alpha y. So here I substituted and I found equation number 11. Okay, so here if I'm going to compare equation number 6 and 11, carefully you have to watch. This value is your 2yc and this is the bracket term 2yc. Equation number 6, chalo equation number 6. Equation number 6 kya hai? What is your equation number 6 here? This one. The bracket term is same, but here the multiplied term was in your equation number 10 is your 2yc. So what I have to do, that it will be equivalent to this one. If I am going to multiply uh, half h cross with this one, then half got cancelled and I can found this one I h cross c. This is minus, that will be plus. So to cancelling this term, I have to multiply half h cross with sigma x dash. Got it? Same thing it is written. It is found that if half h cross will be multiplied with the sigma x dash here, then the RHS of equation number 6 and 11 will be equal and opposite value. Here if I'm going to multiply over here half h cross, so half got cancelled. What I can get? I can get I h cross c and this bracket, which is equal magnitude with equation number 6. But in equation number 6 this value is minus. So here we found plus. If I'm going to multiply this one, so here multiplied factor, what we intend to find out, we found half h cross, right? So now here in equation number 11, if I'm going to multiply half h cross sigma x dash h, this will be value this one. This is your equation number 12. Now if I'm going to add lx, we found lxh. How much we found? We found minus I h cross c alpha z pz minus alpha y pz, which is your equation number 6. Now if I'm going to add lx with this factor here, and this factor value is plus this much, and this commutation value is minus this much. Both are same but opposite. If I'm going to consider uh, sum of these two terms, two operators, lx and this term, then commutation will be 0. This is most important expression that you have to write. These expressions, the equation number 11 you have to write correctly what is the value, and equation number 12 you have to write the correctly, and then this expression. So here we found this is constant or conjugate. What is this one? This one is nothing but jx, that means x a component of your total angular momentum. If it is so, and this is your orbital angular momentum, then what is this one? This one is your spin angular momentum. Okay, so this expression, if I'm going to write in general, then this will be L vector plus this vector half h cross sigma dash vector h will be commute, that means 0. Or we can write this one, this is nothing but jh, or we can write L plus s. Here s is nothing but another operator what we intend to find out. We found this is nothing but your spin. So here L is represents the orbital angular momentum operator, S is represents the spin angular momentum operator, J is the represent total angular momentum operator. So this is in short. I have been not in short. I discussed the discuss this topic. So now most important, how much you have to write for 3 to 5 mark if it is asked in your exam. Carefully, you just watch. Here I have to put the red mark. Okay. See, these things you have to write. These things you have to write. Okay, these things you have to write. These things you have to write. And it is well known that quantum mechanics. These things also you have to write. Here, considering LXH, no need to derive this much. No need to derive. Do not derive these things. Finally, you just write. Finally, you just write LXH. No need to write this one. These things derivation do not write in your exam. No need. No need. But this expression you have to write correctly. Correctly, equation number 6 value write correctly. Here you have to write, by considering the commutation of x component of angular momentum with h, we can found this much. This much. Okay. As I told, these theories you just study well, try to understand and write down in your own language. These lines you have to write. Most important. These lines you have to write, because this is the physics whatever written over here. Okay. Then by considering the x component, like direct here this one sigma dash we have to consider. So sigma dash x component, if we are going to consider, its value will be this much. That means these things also you should not write in your exam. No need to write itself. Okay. And finally you have to write this one alpha x alpha y. No, this is also not required. Finally you just write this one, sigma x component commutation with h will be this much. Equation number 11. Okay, equation number 11. Then you write these things by multiplying half h cross. We found this one, which is exactly matched with equation number 6, but opposite is the value, and this expression, this one. Okay, this much. So if you write this much, whatever I told, it will be maximum 1.5 page or maximum 2 pages. It is more than sufficient for your 3 to 5 mark question. Okay. Okay, go through this. If you have any doubt, you can ask me. Okay.